Hello, students. You're welcome to your favorite educational program, Teaching and Learning on Radio by Niger State Ministry of Education. It promises to be interesting and it comes up every weekday. This is to keep the school children abreast of their curriculum due to coronavirus pandemic that has kept them at home. At this moment, we have our facilitator in the studio who will be taking you on a very interesting subject. Happy viewing. I am Kabir Yusuf.
Class, and today we are considering the topic energy, work and power. Energy, work and power. Now at the end of this lesson, you are expected to know how to explain the concept of energy, work and power. You should be able to explain the meaning of potential energy and kinetic energy. You should be able to use the formula power is equals to work done over time. You should also be able to state the energy transfers that occur when work is done. Now let's begin with work and energy. Now work and energy are two concepts that we usually use interchangeably. Now when your daddy takes you to the farm, for example, when you get to the farm and you perform a certain task from morning till say afternoon, you get tired. Now before going to the farm, you had energy in you. Now when you get back home and you are given another task to do, you usually complain that you are tired and that you do not have energy to do any other work. Now this reveals to us that the more energy you have, the more work you can do. Now if after you have taken some rest and eaten something and another task is given to you, you'll be able to do that work easily because you have gotten your energy back by eating and resting. Now this reveals to us that we use energy and work interchangeably in our day-to-day activities. Now that means that the amount of work you can do is related to the amount of energy you have. So if I want to measure the quantity of work that you can do, I can easily get that by measuring the amount of energy that you have. So energy and work is usually used, or they are usually used interchangeably in our day-to-day speaking. Now energy is the ability to do work. Now energy and work, they have the same units because we use them interchangeably. Now the unit of energy and work is the same, and that unit is called joules. Joules is spelled J-U-L-E-S, and the symbol is capital J. That is the unit of energy and also work. So the first thing that we have learned is that energy and work can be used interchangeably because the more energy you have, the more work you can do. The less energy you have, the less work you can do. Now that being said, we move to the concept of energy. I said earlier that energy is the ability to do work. Now, any mechanical implement or human have a potential energy, that is the capacity to do work. Now, that capacity is expressed in the way that work is being done. Now, there are many types of energy that we know. For example, we are aware of kinetic energy, which is a type of mechanical energy, and the potential energy. We also have other forms of energy like heat energy. We also have solar energy. We have light energy. We have different forms of energy. Now, but for today, we are going to be considering mechanical energy. Now, in mechanical energy, there are two types. They are divided into two. We have kinetic energy and potential energy. Now, potential energy is the energy that a body possesses when it is at rest. When a body is in a position, it has the capacity to do work. For example, if I am on top of a building and I'm holding a stone, that stone has the ability to do work. Until I release it, the energy remains unused. Now when I hold that piece of stone at the top of a building, two very important forces are acting on that stone. The first is the force of gravity, which naturally pulls that stone down to the earth. Now, if I release it, it won't stay in that position. It will fall down to the air because the force of gravity is acting on it. Now, that force of gravity is symbolized by G, a small letter G, and the unit of that force of gravity is meter per second square. Meter per second square. Now, the second force that is acting, or the second thing that is acting on that stone is its mass. Now, the more the mass of the stone, the more work that the stone can do. Now, mass and acceleration due to gravity are now working on that stone. When I release the stone, that stone falls directly to the ground. And if, for example, I have an empty can of malt on the ground, when I release that stone will hit the can and crush the can. That is the work that that stone can do. Now, if you are following this explanation, it will now be easy for you to know the formula for calculating potential energy. I said earlier that two very important forces are acting on the stone: the mass of the stone and acceleration due to gravity, which is G. And mind you, acceleration due to gravity is universal. It has a constant value of 10 meters per second. 10 meters per second square. It doesn't change. In Ghana, it is the same. In Europe, it is the same. 10 meters per second square. So anytime you are doing a calculation that involves acceleration due to gravity, the unit is usually 10 meters per second. All right? Now, we said that another force that is acting on the stone is its mass. Now, another thing that you must consider is the distance. If I am carrying that stone on a distance of, say, 10 meters, the work that it will do cannot be compared to when V squared. The V squared here is the velocity, the square of your velocity. The M there is the mass of what is about to do the work. So half mv squared is the formula for calculating our kinetic energy. You can also say it's equals to mass times the square of velocity all over 2 is the same. Whichever formula you choose to use, either half is 1 all over 2 times mass times velocity times the square of velocity, or you can say mass multiplied by the square of the velocity all over 2. So kinetic energy is the energy that a body possesses because it is on motion. Now let's quickly consider an example. If, for example, the stone that I am holding, if, for example, it has a kinetic, it has a mass of 20 grams. If it has a mass of 20 grams and the height is 8 meters, the height is 8 meters. So we have mass 20 grams and height 8 meters. 8 meters. Now the first thing we'll do is our mass is in grams. Anytime you are giving mass in grams, you quickly convert that mass in grams to kilograms. Your calculation should be in kilograms all the time. Now, how do you convert 20 grams to kilograms? You simply divide by 1,000, because kilo means 1,000. All right, so we quickly convert our mass to kilogram because it's in grams. When you do that, you have 0.02 kilograms. All right, 20 grams in kilograms is equals to 0.02 kilograms. Is that taken? It's easy. Just put 20 all over 1,000. Count the number of zeros here. We have 3. You go 1, 2, 3. That means you have another 0 here, and your point is here. All right, so it's 0.02 kilograms. Now our height is already in meters. We leave it that way. Now we now recall our formula. If the question say calculate the potential energy of the stone, for example, calculate the potential energy. So you come here and say potential energy is equals to the mass multiplied by acceleration due to gravity multiplied by the height. All right, so potential energy will be equals to the mass is now 0.02 kg multiplied by, I told you that our G is a constant and it's always 10 meter per second square. So multiplied by 10 and then multiplied by 8, which is the 8 meters, which is the height. If you do that by calculation, you are going to have 1.6 joules. Potential energy 1.6 joules. If you calculate that, you get 1.6 joules. Also quickly, if for example the velocity of the stone when it is released, if for example the velocity of the stone is 2 meter per second square, or 2 meter per second, if for example the velocity is 2 meter per second, remember that our formula for kinetic energy is K is equals to half mv square. Now before you put in your values, quickly calculate v square. V square is, our velocity is 2 meter per second. 2 meter per second. So you bring 2 meter per second and you square it. The square of 2 is equals to 4. So our v square is equals to 4. So you quickly bring down your formula. K is equals to 1 all over 2 multiplied by our mass is 0.02 kg, and our velocity now in square is 4. If you do that and you multiply everything, you have potential energy equals to 0.04 joules. Now notice that our unit for kinetic energy and potential energy is in joule. Piece of land that I want someone to work on for me. If it takes Mr. A 15 minutes to do that work, and it takes Mr. B 5 minutes to do that work, Mr. B has more power than Mr. A. The less the time used to carry out a particular work or job, the more the power used. I hope you get that concept of power, because power is defined as the rate at which work is done. And each time we mention rate, you should know that time is involved. Anytime you hear the word rate, time is involved. So power is the rate at which work is done. So work done all over time. Work done all over time. Now remember, work done can also be broken down. For example, if you may be giving force and not be giving work done directly, you'll be giving force. Now work done has a formula. Work done is equals to force times acceleration due to gravity, which I told you is G. Force times acceleration due to gravity, which is G. That will give you work done. Now force is force times distance, rather. Force times distance. Now work cannot be done. This brings us to another concept of work done. Work cannot be done until force moves something through a distance. Until force moves something through a distance, work is not done in science. Now, so for example, if I push a car and the car does not move, in science I have not done any work. But if I push a car from point A to point B and the car moves in the direction of my force, that means I have done a work. So for work to be done, there must be a force that pushes a body through a distance. Now work done is therefore force times distance. So power can also be calculated by force times distance all over time. Force times distance all over time. So you have two formulas there for power, which is the rate at which work is done. Either you use work done all over time, or you use force times distance all over time. I hope that is taken. Now let's quickly look at an example. If, for example, if I have a mass of 60 kg, quickly 60 kg, and I have a distance of 7.2 meters, and I'm asked to calculate power. Now quickly, the work done, I said, is force times distance. Force times distance. Now force is mass. First is we said first is work done. Sorry, we said work done is force times distance. Force times distance. Work done is equals to force times distance, because we need our work done to calculate our power. Work done will now be mass times acceleration due to gravity times distance. Our distance is d. Now all over time. So we will now have 60 multiplied by our acceleration due to gravity, which is 10, times 7.2 all over time. Our time here is 10.4 seconds. Now if you do that, your power will be equal to 0, or it will be equal to 401.1 watts. Now, watt is the unit of power. Watt is the unit of power. Anytime you have finished calculating your work on power, the unit is what? Watt. Now quickly, we go to the last concept of energy transfer. Now anytime work is done, there is usually an energy transfer. Now before work is done, there must be a potential energy. That potential energy will be converted to kinetic energy, and that kinetic energy will be used to do work. So for work to be done, there must be energy conversion from one form to another.
Wow! Maybe you had a wonderful time listening to your favorite educational program, Teaching and Learning on Radio by Niger State Ministry of Education. The essence of the program is to educate our children that have been at home due to coronavirus pandemic ravaging the entire world. This program will come your way next time. We do hope you will join us. Kabir Yusuf is my name, and I'm thanking you for watching.